Thank you for joining me for this program on recovery of the large flowered fiddleneck, Amsinckia grandiflora, recent successes after 30 years of experimentation. Jake Schweitzer is the project lead, and I'll be speaking on our behalf. Now, our title refers to 30 years of experimentation, reflecting several ecological studies and attempts at reintroduction from the late 1980s to the early 1990s. The development of GIS tools then allow us to more efficiently assess site suitability across a large area, narrowing down the search considerably. There are 16 species of Amsinckia boraginaceae in California, and 4 of these are rare. Amsinckia grandiflora is one of the rarest, with only 1 natural population remaining, covering about 1/3 of an acre. Some widespread Amsinckia species, such as Menziesii or intermedia, are rather abundant and widespread, and all species of Amsinckia are toxic to livestock. One of the interesting parameters of Amsinckia grandiflora, and a feature of previous studies, is that it exhibits heterostyling. There are 2 different flower morphs, and in this image you can see both of them. These are side by side, not from one plant. So we have the thrum form with the exerted stamens at the top, and the pin form below where the stigmas are exerted. And it's important that pollinators cross between these 2 morphs to get good seed set. The current iteration of this project began in 2011 when I led a stakeholder workshop to encourage interest and activity towards helping to prevent this species from going extinct. The workshop was funded by the Sacramento office of the U.S. Fish and Wildlife Service and included members of various agencies and NGOs and species experts from the Lawrence Livermore Lab, Dr. Tina Carlson and Lisa Patterson. And it also included Dr. Rosemary Stefani from the Bureau of Reclamation. Following the workshop, Dr. Stefani of the Bureau of Reclamation prioritized funding for the large flowered fiddleneck in their Central Valley Habitat Conservation Program. Jake Schweitzer of Volmar Natural Lands Consulting then submitted a proposal to attempt to establish 10 new self-sustaining populations within the species' historic range. The garden, UC Botanical Garden, was in charge of propagation, seeds and seedlings, and outplanting in phase 2 of the project. Mr. Roger Raish of Planet Horticulture Garden Design was in charge of the first 2 outplanting efforts in December of 2014 and 2015. This slide shows the location of the lone extant self-sustaining population. It's on a steep north-facing hillside with rich clay loam soils, and it's in the vicinity of Lawrence Livermore National Lab's Site 300 property, southeast of Livermore, California. The project team was led by Jake Schweitzer, myself, and Roger Raish, with contributions from members of the recovery implementation team, which included Dr. Stefani, Dr. Tina Carlson, Lisa Patterson, Jeb Jerky from California Department of Fish and Wildlife, Kirsten Tarp of U.S. Fish and Wildlife, Doug Bell from East Bay Parks, Jackie Charbonneau of the NRCS, Dr. Vanessa Hanley of our garden staff, Carrie Richardson of a public water agency, and Sam Sosa of CDFW. And again, project funding for both phases 1 and 2 from the U.S. Bureau of Reclamation Central Valley Project Conservation Program. One of the first steps was to embark on habitat documentation. The lone naturally occurring site that's still extant is in the Corral Hollow area at the border of the Alameda and San Joaquin counties. And the range extended to northeastern Contra Costa County around the Black Diamond Mines Regional Reserve of East Bay Regional Parks. And this was one of the sites of an earlier reintroduction program in the early 1990s that did not persist. Habitat includes high elevation grasslands, elevation relative to the area, 244 to 550 meters, And a transition to wooded habitats. Sites were presumed to be very steep, primarily north-facing, well-shaded hill slopes with moist, rich clay or clay loam soil derived from sandstone. And so using GIS tools and habitat modeling, Jake studied the area in regard to the targeted elevation range, percent slope, targeted aspect, which is north preferred, although others were considered, the precipitation range, the minimum temperatures in January, the maximum temperatures in July. And you can see there are quite a few areas that match the habitat characteristics being sought. But it's a large area and we need to combine all these factors to see where suitable sites might occur. So in combination, combining all these values and using some numerical analyses, removing polygons that were less than half an acre in size, and removing polygons that had dense woodland, if we're looking for grassland, right? And also areas that had metamorphic rocks rather than sandstone. And you can see there are quite a few black spots on this map, and using the habitat model, Jake narrowed it down to 90. And these sites were visited in person. Roger Raish accompanied Jake on some of these visits to help assess whether the model actually was predicting sites that were suitable or at least resembled the naturally occurring extant site. These 90 sites were narrowed down to 10, and these were the subject of future introduction efforts. Here are some of the examples of sites that were being evaluated, looking for presence or absence and abundance of rock outcroppings, soil texture, soil color, moisture, pH, and nutrients. There were official lab testing for nutrient quality at each of the sites, measured dominant and diagnostic plant species and their cover, wildflower cover, and site accessibility, super important. And some of that site accessibility included private landowners and getting their agreements to allow access. Potential problems that were used to eliminate sites were severe erosion, excessive weediness, and abundance or signs of seed-eating birds and small mammals. Well, we need material in order to outplant, right? So the garden was in charge of seed production and seedling production. So we used seeds from two different sources, one from the Lawrence Livermore National Lab and one from the Lone Extant site, near Site 300, and planted them into 2-gallon cans, grew them up. These are tomato cages holding the stems up. These are super robust plants in the nursery. We seldom see them quite that large in habitat. This is what care and feeding of an endangered species will get you. The orange flagging you can see on the cages was to indicate a particular flower morph so that we could mix and match and have the pollinators going between the different morphs to maximize seed production. This was also very tempting for our local goldfinches, and they were very much at the ready to eat the seeds as they matured. And so we, after the majority of the flowers had finished, we had to bag these with quick drying cloth bags to protect them from seed predation. We also did the seedlings in 1.5 inch by 5 inch containers, and the seedlings were deemed ready for outplanting as soon as the roots filled the cones and would hold together when removed from the cones. But we also had to time the outplanting based on soil moisture levels in the field. The site planting design included plots that had fenced and unfenced areas to examine the effect of trampling, potential trampling by grazers. All of these sites have some aspect of cattle grazing, sometimes sheep grazing. And so for the first 2 years, 40,000 seeds were direct sown, and 4,000 seedlings were sown at the 10 initial sites. Subplots were examined each spring late March, early April at peak flowering. The height, the morph type, the number of branches of each plant were assessed and categorized, and space was left within each plot to come back and do additional outplantings. And this is part why the half-acre polygons or smaller were eliminated from initial consideration. Here are our staff, garden staff, preparing to outplant. This was in December of 2020, hence the masks. And you can see the containers are really ready to go. This was actually a very dry time, and it required irrigation post-planting to get them into the ground and make them happy. You can get a sense of how steep these sites are. This is a north-facing site, and the camera is looking east toward the Central Valley, and you can see quite a bit of residual dry matter. This is a site that's been very successful, and you will see pictures to show a lot of plants coming. So after the initial plantings, the plots subdivided, parameters recorded. We counted how many plants there were at each site, plant height for a subset of these plots, the number of branches as a substitute for an actual seed count, what kind of flower morph ratios there were, and the phenology, the timing. Any problems such as burrows, damage, weeds were also recorded. Photographs were recorded at each plot and at the roble samples. This multi-scale approach allowed for tracking the number and vigor of populations within different portions of individual plots, between plots, and across entire reintroduction sites. So what did that get us? Well, the first 10 sites were narrowed down to the 4 most successful, and 2 of those successful sites were relatively close together and have actually merged, not only because of our own choices, but because the plants are showing up, the seedlings are coming up well outside the planted areas and are merging the 2 populations without our assistance. You can see in 2015, the numbers in these plots were relatively low and nowhere near the 3,000 we'd like to have at each population to be self-sustaining. But you can see by 2021, we well exceeded 3,000 plants per plot. And we hope that this will continue, but we won't know unless we continue to monitor. So what are our lessons learned? Well, we encourage you to consider using private lands for reintroduction projects. You can enter into a safe harbor agreement between the landowner and agencies. And that for most grassland-associated rare plants, grazing can be essential, especially where fertile habitats are required. But it must be monitored to reduce potential damage, for example, trampling. The use of seedlings rather than seeds may be worth the short-term additional costs associated with management, which can include irrigation if rainfall patterns don't cooperate with your outplanting timing. And you should consider the minimum viable population size for long-term persistence. Our goals for the future are to continue monitoring, which will require more funding, and to help establish easements in cooperation with private landowners and land trusts or other organizations to keep these species going out in the world. With that, I would like to acknowledge the Recovery Implementation Team, Contra Costa Water District, East Bay Regional Parks District, previous practitioners who've worked with this species, and various landowners, rangeland management expertise of the NRCS, and the many private landowners who granted us access to their properties, as well as the UC Botanical Garden staff and volunteers for their participation. Thank you very much.